So let's talk a little bit more about these imaginary numbers. Now, imaginary numbers are a part of what we're dealing with here, but what we're really interested in is what are called complex numbers. Now, complex numbers are a combination of a real number and an imaginary number. And all complex numbers can be written in the form a plus bi, where both a and b, those coefficients, are real numbers. So this is some real number plus some real number multiplied by I. And just like I used R here to represent the real numbers, the set of all complex numbers is denoted by the letter C with that line there to show that it's the complex numbers. Now let's think about how this relates to all the other numbers. Now, much like we did with those equations right at the beginning of this, we started with our natural numbers. They are sort of our basic numbers. And then on top of that, we build our integers. Our integers are all the whole numbers, including the negative numbers. And then on top of that, we build the rational numbers. The rational numbers are all numbers that can be written in fraction form. Now that includes all integers, because we can write 2 as 2 over 1, or negative 3 as negative 3 over 1. It can be written as fractions, and we get the rational numbers. Now on top of that is our next set of numbers. Our next set of numbers is the real numbers. Now up until today, that was all the numbers we knew. That included things like pi and root 2, which was our irrational numbers. And now we have the outer box for this set of all possible numbers, which is our complex numbers. So our real numbers, for example, we have things like pi or root 2. Our rational numbers were things like 3 over 2 or even 1.1. Our integers were things like -7. Our natural numbers were things like 2, our counting numbers. And our complex numbers brings in a new type of number. For example, something like 1 plus 2i. And those are the type of numbers that we're going to be looking at in these last couple of lessons. Now, some more terminology. Generally speaking, we use the letter Z to represent complex numbers, whereas we use X to represent real numbers and N for natural numbers. So when we're looking at something to do with sequences, for example, we often use N because our answer is going to be a natural number. When we're solving what are called real equations, we tend to use X. And when we're solving complex equations, we tend to use Z as our letter to represent that. Now that gives an indication that which set of numbers we're in. It's not a hard and fast rule, but that is generally the notation that we use. Now, if we have a complex number Z, which is 3 plus 2i, then we can define the real part of that, which is represented by Re of Z. The real part is just the real number, in that case 3. And the imaginary part of that is the coefficient of I, which in this case is positive 2. So the imaginary part is how many i's we have, and the real part is how many non-i's we have within our complex number. Now, if a complex number has a being equal to 0, that is, it's just bi, it is known as a purely, or sometimes just imaginary number. An imaginary number is one with no real part. And if b is equal to 0, that is, there's no imaginary part, it is known as a real number. Those are ones that we have been dealing with for a long time. Now finally, one more word is the conjugate. Now the conjugate of the complex number, a plus bi, is denoted z and then a star symbol. And the conjugate is a minus bi. That is, the real part stays the same, but the imaginary part becomes negative. So the real part of z conjugate is the same as the real part of z. It is just equal to a. But the imaginary part of z conjugate is equal to the negative of the imaginary part of z. Is it equal to negative b? That's going to be really, really important when we come on to looking at some of the operations, particularly division. But we'll also see there are some very important properties of conjugates that we can use sometimes to help us solve problems. Now, conjugate, often people remember when they see the word conjugate. Sometimes when they see this notation, Z star, they forget that's what that means. So just be on the lookout for, if you see Z star, that means the conjugate of the complex number Z.